Hey guys, so welcome back. So today in this lesson we're going to be talking about power. So mostly for non-calculus physics, what our major concentration is going to be is on the average power. So the bar on top of it just means average, um, and the formula is work right here over change in time, which by definition from our work energy theorem can be the change in work over the change in time, and the units that we're going to be using are called watts. I know what a lot of, and it's denoted by W. I know what a lot of you may be thinking. It's like, oh, wait, W, I thought it was work. Now it's watts. What is going on? Yeah, I'm there with you guys. So just, label it probably work from now on. So spell out work. And then because watts is just W as well. So make sure you don't get them confused, units and a definition, because that may cost you some points in your exam. All right, so now let's go ahead and start working an example right here. So let's suppose you're climbing something, and you're going up, your house or something, and there is a ladder right here that you're trying to climb, and the height that you climb at the end of the day is going to be 10 meters, and 10 meters, and you go from here to being on top of the building, which is right here. All right, and now it takes you 4 seconds to climb that up, and also you weigh 80 kilos, 80 kilograms. Now the problem may ask you, what is the power that it took you in 4 seconds to climb up the 10 meters? So now we're going to say, all right, power, average power, is going to be equals to work or the change in energy. So now look from here to here, what was the only thing, let's use energy first. So what was the only thing that changed from bottom to top? Just the height, right? From your center of mass, you just went up 10 meters, right? So then that means potential energy. If the only thing changed was the height, that means potential energy, right? Potential energy over change in time. But we can also think about it as, what were we overcoming as we were going up? Force of gravity, right? And how much did we have to do it? Well, the height, right? Change on y over change on time, right? So notice how these two concepts come across from each other. So work and energy right here. So now let's go ahead and compute that. So because remember, this is work. So before we move on, work is force times distance, right? Force of gravity that you were overcoming times the distance you moved. All right, so now let's go ahead and just plug in numbers. So from our previous lectures, remember that potential energy is just mg, change in height, or delta y, right, over change in time. Notice that now they're becoming very, very similar. At the end of the day, both of them becoming similar, because force of gravity is just mg, gravity times change in height, change in height. It's pretty much the same thing, right? Except that in the future, we might use them to find, for example, you're given the potential energy change, and then you're given the force, and then you need to find the change in the height or something like that, or the time, etc., etc. It's just, tweaking things, moving things around. All right, so now let's compute the numbers. What was the mass? Well, the mass was 80 kilograms, because that's the mass of the person or the object that is going up or moving. What's gravity? Well, that's 9.8 meters per second squared. What is the change on height? Well, let's say you were at 0, right? And you went up 10 meters. So change in height means final, which would be 10 meters, minus initial, which you started at 0. So, it would be 10. But just so it makes more sense, because change means final minus initial. Change in time, it took 4 seconds. That's the change in time. Or you can say 4 seconds minus 1 second. Sorry, 4 seconds minus 0 seconds, if that makes you keep units a little bit more and helps you understand and keep track of where things are going. So now this is a moment where I tell you pause the video and put these numbers in your calculator and make sure you're getting the same numbers we are getting. So after putting all this into our calculator, we get 1,960 watts. So now that is the power that you are exerting by going up 10 meters in 4 seconds. Now, some questions may ask you, okay, what happens if you reduce this time by half? So that would mean, cutting it in 2 seconds. Well, what would happen? This would get cut by half, right? So then instead of 4, now it's going to be 2. So that means instead of cutting this, dividing, let's just say x, which would be the top divided by 4, now the new one would be x divided by 2. So your power needed would double because you did it twice as fast, which makes sense, right? For example, like how much force do you need to carry 5 pounds? Let's just call that force F1. How much power or force do you need to carry twice as much? Twice as much force. So that's why. And then, what happens if you went slower? Well, the slower you went, the denominator becomes greater, which means that your entire solution becomes greater. So then, smaller. So for example, in that case, with 8 seconds, it would be x over 8, which your solution decreases, right? So that means that as your time increases, the power necessary decreases. So the slower you do something, the less power of it that you need. So I hope this helped. Let us know in the reviews if it was helpful, what we can do better. Remember to follow us on Facebook, YouTube, check out our channel, and just recommend us. Good luck with studying, and email us. Let us know what you think, what we can help you with better, and something that you want to see explained or work out. And we'll try to do our best. So good luck studying.